the next thing on our agenda is going to be security. Now, here I have to put things a little bit into perspective. Now, we are talking here about CCIE routing and switching exam. That means that, yeah, security is part of it, but it's not going to be a terribly, terribly big emphasis on it. Why? Because there is a CCIE security, which we also provide training for, which, by the way, is very, very good. It's awesome. It's the best in the world. So go and take that class. But for the CCIE routing and switching, the emphasis on security is mostly going to be on securing the infrastructure. So what I mean by securing the infrastructure is basically the routing protocol security, it is going to be LDP security, it is going to be things like private VLANs, and maybe zone-based firewall. Now, I'm saying maybe because you may or may not see it. Now, if you take a look at the blueprint for CCIE RNS, I mean, almost any single security topic in existence is actually mentioned there. Now, I find it very, very unlikely that they would be asking you anything about, for example, iOS IPS, or that they would be asking you anything about the CBAC, the old firewall in iOS. But these things here, you really, really need to know in and out. Also, when it comes to basic things like, for example, the access lists, you should really feel comfortable with these things. So I'm going to start here by talking about routing protocol security. And when we are talking about the routing protocol security, really what we are talking about are things like authentication and maybe filtering. So, you know, filtering in different routing protocols is done differently. So we talked about this already to some extent about routing protocols. So here I'm going to talk about authentication. Now, all routing protocols that you have in the lab support authentication in some way. So for example, RIP version 2 supports two forms of, or actually I should say three forms of authentication. It supports none, it supports plain text, and it supports MD5. Now, none is easily done. It is always configured. It's when you don't use the authentication. Now, for the text and MD5 authentication, I should point out that you are expected here to create the keychains and then reference the keychain on interface. And finally, specify the type of authentication to use. Okay, so this should be relatively straightforward. But just like with everything, be on a lookout. When you are using MD5 as the authentication for RIP, I have seen situations where it's known to fail. Now, what I mean by that is that you would configure it properly, you think that it's configured on both sides of the link correctly, that you have configured your keys, your keychains, that everything is in order, and for some reason it doesn't work. You are seeing the updates being sent and they are failing the authentication on the other side. If this happens, my suggestion is remove all the RIP-related configurations, put them back in, and in many cases this works. Sometimes reload works as well, but I wouldn't go ahead and just blindly reboot my routers in the lab just because one thing doesn't work. If you encounter this situation, my suggestion is try to handle it with as little impact as you can possibly do, but don't spend too much time on it. Now, I'm perfectly sure that Cisco knows about this problem with that version of iOS that they have in the lab, and that you are most likely not going to be asked to use MD5 authentication. Also, one thing that you should know is try to avoid key number 0. So So use any key other than key 0 because RIP doesn't seem to like it. Now, when it comes to EIGRP, again, it's relatively simple. We have either none authentication or we can have MD5. Again, if you are using MD5 keychains, keychain reference on the interface, I should say reference here. And type of authentication to use. Now, even though EIGRP supports only one authentication type, you still need to sort of specify it. But that's pretty much it. There is really nothing more to EIGRP authentication. This is what you need to keep in mind. Now, you might be expecting now the real deal begins, and you would be right. OSPF is a really tricky one, unfortunately, because OSPF is always authenticated. You cannot have no authentication in OSPF. OSPF always has authentication enabled. So you can see here that for RIP we have said none, and EIGRP we have said none. For OSPF it's actually an authentication type that is called null authentication. Now, I know that this may sound like semantics, but it's actually very significant. So we have null authentication, we can have plain text authentication, and we can have MD5 authentication. Now, in both cases, or sorry, in all three cases, this can be either configured on per area basis or per interface. And no matter which one of these you use, what you are actually doing, you are specifying the authentication type to use. Now, in addition to specifying the authentication type, what you actually need to do is specify the key. And the key is always specified on interface. So you can specify the authentication type per area or per interface, where basically per interface will override per area, but you cannot specify the authentication key per interface. You can only specify it on an interface. So let's now do a couple of examples here. So what I'm going to do now is I'm going to go to my network. Oh, this is not actually what I wanted. This is what I need. And I'm just going to bring in two of my routers. I'm just going to say R7 and let's say R8. So they do have, actually, you know what? I'm going to use two different routers here. I'm going to use R6 and R9 because I actually have multiple interfaces between them. So here, if I do show CDP neighbors, you'll see that I have neighbor on serial 020. There is something pre-configured here, just an IP address. So let me configure a link between them. So I'm going to use serial 021, and I'm going to use 96.6 on this side, and on R9, show run interface serial 020 and 021. So here, let me use 96.9, so I'm going to do no shutdown here, and this interface should change state to up. Now it does. So let's first do an example of RIP configuration. So what I'm going to do here on R6 first, I'm going to start by defining the keychain. So I'm going to say keychain, and let's call it RIP authentication. And here inside the keychain, I can specify the key, and I specify the key identifier. As I said, stay away from key number 0. In any case, just stay away from key number 0. The easiest is to remember, don't use it. Use key number 1, and here you can specify the validity time of the key. When do you want the key to be valid, during which periods of time? If you're not asked to do that, just simply specify the key string And I'm just going to say IP expert here. And if I do show run keychain, sorry, do show run section key. So this is what I will see. I will see that I have a keychain RIP authentication that uses key 1, key string, and hide key is no idea what it is, but I don't actually think it's part of this. Or actually maybe it is, but interesting. Show run. Let me just see. Never seen that particular command. No, it wasn't actually part of it. It was part of something else. So this is why I've never seen it before. Now, this is on R6, and I will be using the exact same thing now on R9. And on an interface between them. So let's configure RIP to run here. So I'm just going to say router RIP, no auto summary, version 2, and I'm going to say network 192.168.69.0. So this is where I will be running it, and let's run it on the loopbacks. So loopbacks are configured. So network, actually I can copy paste this. So this is going to go, oops, this is going to go here, and this is going to go here. So if I do show IP route RIP, I should be getting the route updated there. So what I'm going to do next is on interface serial 020, I'm going to say IP authentication. And here I can specify the mode, and this is specifying the authentication for RIP. Oh, actually, sorry, IP RIP, just one second, authentication. And I can specify mode, and I can specify text or MD5. Let's try MD5, and I'm going to say IP RIP authentication key chain, and I specify that I want to use my RIP authentication keychain. So if I do debug IP RIP events, I'm now going to be waiting for an update to arrive from R9, and let's see what happens when it actually does. And I will see here that we are ignoring the packet from 192.168.69.9 because it actually has an invalid authentication. So let's now correct this issue on R9. So interface serial 020. Did I actually configure the keychain there? Yes, I have. And I'm going to say IP RIP authentication mode. I'm going to say MD5, and I'm going to say IP RIP authentication keychain RIP authentication. So now when we receive the new update within 10, 15, 20 seconds, we should be actually accepting this authentication. So let's wait for this to happen. And you know how patient I am for very, very brief periods of time. So this was our update going out. And now, let's see. There we go. We have received that update, and now we have actually accepted the update. So we can see that RIP authentication worked. And also, this is the only way to troubleshoot the RIP authentication, is to actually run debug IP RIP events and actually see that it is giving you an invalid authentication. So the invalid authentication would be when you are using a default type. Now let me show you how it looks when you are having a wrong key. So here I'm just going to go to keychain, RIP authentication, key 1, and let's say key string Marco. So I want to break it up a little bit. So here show, let's do the debug, do debug IP RIP events. So when this update now comes in, so let's hope that it's going to, there we go, and it's also going to tell us invalid authentication. So we can't really say, was it the wrong password or was it an invalid authentication type. So this is RIP. Now let's take a look at EIGRP. So I'm going to run the same example here. So now these two routers are disagreeing about their RIP authentication. So I'm just going to clear IP routes. So there are not going to be any RIP routes in my routing table. So let's configure EIGRP between these two. So very quickly, again, router EIGRP. between them, no auto summary version, and let's run this on a different interface here. So this goes on R9. Let's see, for EIGRP, of course I need the AS number there. So this goes in. Oh, come on. Let's see, what am I doing wrong? No, it's on version 2. Of course, there is no version 2 there. So let's do that, and let's do that. And one thing is no version, because there is also a version command in that goes on the top of the show running config. So this is what I was setting here. And this is actually used to sanity check your configurations if you're trying to save it with a newer version. So it doesn't actually affect behavior in any way, it's just a cosmetic thing. So now if I do show IP route EIGRP, this is what I will be seeing. And let's configure the keychain there. So I'm going to say keychain, let's say EIGRP authentication. I'm again going to use key number 1 and let's say key string IP expert. So this is what I'm going to configure. So this goes on R6 and let's put it on R9. And then on the interface serial 021, I'm going to say IP authentication. So now it's IP authentication EIGRP, actually mode MD5. So this is the only mode that I have available for EIGRP 96. The only option that I can actually specify is MD5. And then I'm going to say IP authentication keychain, and here I specify again EIGRP 96, and I specify the name of the keychain EIGRP auth. So this is the configuration of serial 021 interface here, and as you can see, these are very, very long command, but they're kind of ridiculous command. But when you type IP authentication mode, of course that the only option is EIGRP. And why is the authentication for RIP configured as IP RIP authentication, and here it's not IP EIGRP 96 authentication? It's just iOS consistency. You have to remember these silly things. I can never remember them. As you can see, I actually have to pick my way through this, and you know, sometimes that's also okay. So now, at this moment, there is a situation that on R6 I actually have authentication configured, but I don't have it configured on R9. And this is, if this was a troubleshooting scenario, this is where you would encounter this. Now, if you do show IP EIGRP interfaces on R6, you are not going to see any neighbors, right? Because they're failing authentication. Now, if you want to run the debug, you have to remember one thing, and that is that EIGRP is a very complex protocol. EIGRP supports multiple routed protocols. So it can provide routing for IP, IPX, and AppleTalk. And it can provide routing for IPv6 in its EIGRP version 6 version. But that means that there are some protocol-dependent functions and some protocol-independent functions in EIGRP. One of the protocol-independent functions of EIGRP is the authentication. This is why if you actually want to see the hello packets that are failing the authentication, you must not run debug IP EIGRP and then whatever. You actually need to do debug EIGRP because it's protocol-independent packets. Now, when you run debug EIGRP packets, you're going to be running update for all of these packets here. Now, let's wait for EIGRP hello to come in here. And we are going to see here that we are receiving a packet that we are ignoring on serial 021 because we are missing authentication. So now we are told that authentication on the other side is actually missing. It wasn't configured. So I do have a keychain configured on this side, which is EIGRP auth. So let me go in and let me break it a little bit. So I'm going to say that the key is actually Marco. So interface serial 021, I'm going to say IP authentication mode EIGRP 96 MD5, and I'm going to say, now let's see what's happening now. Now when we receive the hello, there we go. Again, we are still getting missing authentication because I have not configured the key. So I'm going to say IP authentication keychain EIGRP 96, and then we specify the keychain, which is going to be EIGRP auth. So now, when we start receiving hellos, let's see what the message is going to be. Is it going to be any different than the one we have? Now, take a look at this. Now we are receiving slightly different message. We are not receiving missing authentication that we were receiving before, so there is missing authentication. If we don't configure the authentication type or the key, now we are actually getting an invalid authentication. So you can use these two messages to determine whether you need to actually add the authentication or it might be the actual password problem. So if you have missing authentication, that means that your configuration is incomplete. And if you have invalid authentication, it basically tells you that you are using the wrong password. So now what we need to do is actually go ahead and fix it. But you know what? I'm not actually going to fix it because I like it being broken. Now, I like it being broken because I want to add another protocol here to the mix, and I don't actually want these to exchange the routes. The protocol that I'm going to add now is, of course, going to be OSPF. So let's go ahead and configure OSPF here. So I'm going to say configure terminal, router OSPF 1, and I'm going to say network 192.168. Let's run it on 69.0. Actually, yeah, 69.0 and network 192.168.0.0. And of course for OSPF, don't forget Marco. Of course I need to specify the area. So this goes on R6, this goes to R9. So now OSPF is going to form the adjacency there, but let's configure now on R9, or actually on R6, let's configure area level authentication. So I'm going to go in here, I'm going to say router OSPF 1, and I'm going to say area 0 authentication, and I will have three options here. Actually, area 0, let me show you what I have here. I can have authentication, message digest, or I can specify the carriage return. Now, this actually doesn't give me three options, it gives me two options, but there are three options when you specify this on per interface basis. So if I just press area 0 authentication, if I press enter now, this is configuring the plain text authentication. So let's take a look at that. So now I'm configuring area 0 authentication, and let me clear. I'm going to clear IP OSPF process. So now I'm going to say do debug IP OSPF adjacencies. Let's see what is happening there. Now let me do the same thing on R9. So I'm going to say clear IP OSPF process, just to speed it up a little bit. So now when they start forming an adjacency, this is the error message that I'm looking for. Now it says mismatch authentication type. OSPF is a two-stage authentication. The authentication type needs to match first, and then if authentication type matches, the authentication strings will be compared. Now, in this case it says that input packet has specified type 0, and type 0 means null authentication, and we use type 1. Type 1 is plain text. So now we have a situation that we have mismatched authentication type. Now let me go and change the authentication type on R9. So router OSPF 1, area 0 authentication. So now I'm changing authentication type. I'm not specifying the password in any way, and take a look. What is happening now is OSPF actually fully formed an adjacency. That's okay, because the authentication type matched and the authentication string matched. No string and no string. That's actually a match. Now, if I specify the password, and this must be done per interface, so interface serial 0 to 1, I'm going to say IP OSPF authentication dash key, and here I can specify password IP expert. So if I clear the session now, so if I say here clear IP OSPF process, let's clear it here, and let's say now it's going to go down. So let's say clear IP OSPF process, yes. Why is it going from full? Oh, did I configure the wrong interface? I think I did. Yes, no I didn't. Yes, I did. I configured the wrong interface. I apologize for that. So I'm going to go here. I'm going to specify the authentication key. Let me clear this. I'm going to clear it from the other side. So now, take a look at this. So now, my authentication type does match, but now the keys don't match. On one side, I'm not using anything, and on the other side, I'm using the key. So here it says mismatch authentication key, clear text. So this immediately tells me, hey, you actually have a good authentication type, but your keys don't match. So let's fix that. On R9, I'm going to say IP OSPF authentication key, okay, on the interface level, so interface 0020, IP OSPF authentication dash key, and I'm going to say IP expert. So now when I do that, my adjacency is actually going to form. So let's take a look at that. There we go. So the adjacency is actually forming now. Now let's go on R9. So on R9 here, I have per area specified authentication. So this enables plain text. So now I'm in the interface level. So here I'm going to say IP OSPF authentication, and here I have three options. Message digest, just press enter, which would set it to plain text, or null, use no authentication. So I'm going to say message digest. So now on this interface, I am actually overriding the authentication type that is in use. So if I go on R6 here, I'm again going to get a mismatched authentication type. So here it says the input packet specified 2, which is the MD5, and we use type 1, which is basically a plain text. So now let's again on R6 fix this problem. So I'm going to say IP OSPF authentication message digest. So now this is going to match. Now the OSPF now forms the adjacency, but if you did this in the lab, you'd be making a terrible mistake, because take a look at the configuration on serial 020 on R9. What we have configured here is that we are using authentication message digest and the password IP expert. Well, wrong. What we are using is authentication message digest and no password, because this command here does not apply to MD5 authentication. This command here applies only to plain text. Now, if you want to set the MD5 password, what you have to do is IP OSPF message digest key. You specify the key, MD5, and then you specify the password. So now we are actually specifying the password to use with message digest authentication, which is what we can see now, is that we now have a mismatched authentication key. So OSPF is actually telling you always exactly what's wrong. So let's fix this. So I'm going to say IP OSPF message digest key 1 MD5 IP expert. So now when I set this, my authentication is actually going to be working just fine. So let's wait for the adjacency to form. Show IP OSPF neighbors. Let's see. Oh, we are full. I somehow missed it, I guess. It stayed active, so it didn't actually, I was faster than 40 seconds, so it never actually went down. So we can do the undebug all. There is one more protocol that remains when it comes to the routing protocols, and that is, of course, BGP. So BGP also does support authentication between the neighbors. So when we have the neighbors that are configured here, we can specify the password for the neighbor, and the only supported authentication type is, of course, MD5. It's very, very simply configured. It's configured on the neighbor, and then we specify the neighbor password, and we specify the password string. You have to configure it on both sides. If you don't configure it on both sides, you are going to get TCP authentication errors. And if you see there port 179 mentioned, you know that you are dealing with a misauthentication in BGP. It will be very difficult for you to figure out, is it configuration missing on the other side, or is it the wrong password, because there will be nothing in that log message that indicates either one. But if you have access to the other side, you can always take a look. Because it's MD5 authentication, you can't actually pick up the password from the line in any way. So, you know, there is no debug command that will help you determine what the password is on the other side. Now, going back to this list here that we said that we were going to talk about the routing protocol security and LDP security. While on the subject of LDP security, I should point out that really the LDP works in a very, very similar fashion to BGP. Again, between the neighbors on the TCP session, we can enable MD5 security, and instead of using router BGP, for example, here, so let's say that this was an example with router BGP X. If we used LDP, it would be MPLS, LDP, and then the exact same syntax here. Neighbor, we would specify the neighbor, which needs to be the LDP ID of the neighbor, and then we will have password and string. And again, we're going to have the TCP authentication error, and in case of LDP, we will be dealing with port 646. So this is for LDP, and this one here would be for BGP. But otherwise, they're very, very similar in the fashion in which they operate. Now, when it comes to the LDP authentication, so I'm just going to spend one more moment on it. The important thing is to see that you can see whether it's enabled with show MPLS LDP neighbor, but it's important to run detail. Now, one of the things that you should be looking here is the TCP session. You will have IP address port, and then something something IP address port, and then MD5 on. Now this MD5 on, this is what you are looking. This will tell you that MD5 is actually operational on this session between these two neighbors. Also, below this you will have password, and it's usually going to say not required. This is okay. It will say that it was configured on the neighbor. This is okay. And then you are going to have one of two options. Stale, which means not good, or you are going to have in use, which is good. Now, if you have stale, if this is the case here, that means that configured password, so we can say that password is configured, or I should maybe say was configured, after session was established. And if this is the case, what you will see is that this here, this MD5 on, will not be visible. So if you have stale, you will not see this MD5 on. So you will have two indicators that something is wrong with your configuration. If you have in use, then this bit here will be in place and will be visible in your show MPLS LDP neighbor detail. Now keep in mind that if you don't use the detail keyword here, you will not see any information about the LDP authentication. Even though this line, the TCP session line, will actually be showing, it will not be displaying this part about MD5 on. Again, I would really like to meet that person in Cisco who decided that this was a good idea.